And I do post to YouTube as well now. And so, I'm trying to build that up. It's tough to keep up with all the social media though, let me tell you.
Oh, I know that.
But, it's like you got to do it. So, all right. If you are ready,
I'm ready.
okay. In 3, 2, 1. Hi, everyone. Welcome to Sandy K Nutrition, Health and Lifestyle Queen. Today with me, I have a return guest, the wonderful Dr. Richard Johnson. He is a professor of medicine at the University of Colorado in Denver and has been a practicing physician and clinical scientist for over 25 years. He's internationally recognized for his work on the role of sugar and its component fructose in obesity and diabetes. His work has also suggested a fundamental role for uric acid in metabolic syndrome. Now, Dr. Johnson is a prolific scientist with research that has been funded by the National Institute of Health since the 1980s. He's a member of the American Society for Clinical Investigation and has published over 700 papers. He's lectured in over 45 countries and is a highly cited scientist. And he's also the author of the books, The Sugar Fix, The Fat Switch, and his newest book, Nature Wants Us to Be Fat. And today we are going to talk all about sugar. And who doesn't have a little bit of a sweet tooth, right, Dr. Johnson?
Oh, even I tell you, yeah, I write about sugar, but I definitely have a sweet tooth. So,
Well, welcome. And I'm excited about this topic because I actually saw a stat yesterday. Oh my gosh. And I wish I remembered the numbers, but it compared how much sugar we ate. I think it was from like 1950 in comparison to now, something like 175 pounds of sugar a year for Americans. It was unbelievable. So it's a good topic to get into.
yeah, I mean, back in 1700, the average sugar intake was only 4 pounds a year. And it's over 150 pounds a year now. And people love sugar, and they love this high fructose corn syrup, which is just like sugar. And in fact, these two added sugars make up about 1/6 of all the calories we eat. So about 15% or so of our caloric intake, our energy intake, is from added sugars. So we love sugars. There are some people who eat almost a quarter of their diet as sugar.
Yeah, it's a good thing my husband doesn't listen to this podcast because,
Put away those cookies.
I do catch him in the pantry. Anyway, it's a walk-in pantry, so he'll go in there and hide, and I ask him what he's doing in there because I'm always a believer in a little bit is okay. Everything in moderation is okay. It's when it gets excessive. So that's why, my kids rebel against me if I try and keep it away from the home. They're old enough to go to the car, get in the car and buy it themselves, right?
Right. And, actually, if you severely, prevent people from eating sugar, it can actually backfire where they start craving it so much that they will sneak off and get sugar at some point. So like they had this thing where if you restrict sugars completely in schools, there's this syndrome where when the kids get out of school, they go straight to the candy store. But having said that, I mean, it's really a wise move to try to restrict sugar and to try to reduce sugar intake because it really does have a lot of bad side effects, bad problems that it causes.
So let's get into the different types of sugar because I don't think people realize how much sugar is hidden. And okay, we all know fruit is sugar, right? Fruit is fructose, right? And what other kinds of sugar is it? Isn't it all like they're not all created equal?
Yeah. So sugar 101, let's go through that.
Yeah, let's do it.
So exactly. So table sugar is known as sucrose, the white sugar, white powdered or white crystalline sugar, the classic sugar. And sucrose consists of a glucose and a fructose molecule that are both bound together. So sucrose is half glucose and half fructose. So table sugar. High fructose corn syrup is really almost the same thing. It's glucose and fructose mixed together, and there's usually a little bit more fructose because it's a little sweeter. People like that sweet taste. And so those are the two main added sugars. They both contain fructose and glucose. And then there's just pure glucose or dextrose, and that's the main sugar in our blood. Glucose is what circulates in our blood. When it's high, we call it diabetes, and when it's low, we say we have hypoglycemia. So glucose is like the main fuel that our body uses. And then fructose by itself, that's the sugar that's commonly present in natural fruits and in honey, fruit juice. Now, fructose, it turns out that when we do the research, and we did a lot of research on this, the fructose is actually the bad guy. Fructose is the one that tries to get us to store fat. So glucose is really used for more immediate fuel, and fructose actually activates a process in our body where we try to store energy as fat. And so it's a little bit odd, right? Because natural fruit is healthy. And yet I'm telling you that, fructose is the bad guy. Well, it turns out that natural fruit is good. And the reason is that first, natural fruit does have fructose, but a natural fruit only has a small amount, like 3 or 4 grams of fructose, or maybe a little bit more. But it has all these other things that are really good. It's got fiber and potassium, and flavonols and vitamin C, and all these things that actually counter the effects of fructose to store fat. And so if you just eat, 1 or 2 fruits, you're not getting too much fructose. You're getting all these good things and all the fiber and everything. And also our intestine actually removes the first 3 or 4 grams of fructose. It kind of converts it to glucose, actually. And so the fruit, you don't get that much fructose to your liver with just eating a natural fruit because it's sort of inactivated in the intestine. But when you drink a soft drink, you're getting like the equivalent of like 7 or 8 fruit all at once without all the good stuff. And it's liquid, so you absorb it rapidly. And so that wave of fructose hits the liver, and it's the concentration that causes the problem. So if the fructose concentration is high, it activates this switch that makes you want to convert the energy you're eating into fat more than into active energy, or ATP. So that switch is activated by fructose and usually a high concentration. So natural fruit turns out to be quite healthy. We've done studies in people where we put them on a low fructose diet, which really means eliminating or reducing sugar, table sugar, and high fructose corn syrup, because those are your major sources of fructose. And then we give natural fruit supplements. So they actually get some fructose back, but in the form of fruit. And they actually do very well because of all the reasons I just explained. So, yeah, so in terms of sugar, it's a little confusing. Fructose is the bad guy, but natural fruits, even though they contain some fructose, are good. And but when you drink fruit juice, like apple juice, you get a lot of fructose, and you can activate this biologic switch by drinking a glass of apple juice, for example. It's got about the same amount of sugar as a soft drink. So it's sort of depressing because a lot of us love juice, and it's probably not good for us. And little children, when they're given juice, it's actually a major cause of obesity in children. And, you know, the pediatric societies, the physicians and the pediatric societies have recommended reducing juices in children. And we found that the fruit juices don't just cause obesity, but we found that they actually can make the gut permeable to proteins like peanuts, and that can give you allergic reactions. And so we believe that the sugar in fruit juice, the fructose, actually is probably responsible for why kids develop food allergies, because it makes the gut permeable to things like peanut proteins that normally don't get into the blood. And when they do, you have to get into the blood to have that allergic reaction.
Wow.
So,
I've
yeah.
never heard that about fruit juice making the gut permeable. I've
Yeah,
never heard that.
So I'll tell you the story behind that. You know, I was at a meeting where this guy was a very famous allergist, was proving how animals develop anaphylactic shock to peanuts. And what he did was he took a mouse that was genetically susceptible to allergies. So you have to have some genetic susceptibility.
Yes.
And then you have to get those peanut proteins into the blood. So if he just feeds them peanuts, even though they're genetically susceptible, they don't get anaphylaxis. But what he did was he had to make the gut permeable to the peanut antigens or the peanut proteins. And the way he was doing it, he was giving cholera toxin. You know, I mean, that's a pretty terrible way to do it, because, you know, cholera is this terrible disease that causes diarrhea and wastes people. And the toxin makes the gut very permeable. So he was feeding these little mice cholera toxin with the peanuts, and that allowed the peanut proteins to get into the blood, and then the mice would anaphylax. They'd have a severe allergic reaction. So I was listening to him and I said, yeah, he doesn't need to give cholera toxin. All we had to do is give them fruit juice.
Wow.
All we had to do is give them fructose, because that'll make the gut permeable. So I went up and talked to him after his lecture, and the two of us ended up doing some experiments. And we found that when we gave liquid, you know, soft drinks or fructose juice, we could make the gut permeable, and the poor little mice could anaphylax. So I think that, you know, there's been a dramatic increase in food allergies in children. And I think it's related to this common thing of giving fruit juice to little kids. And what it does is it makes their gut permeable, and they like the juice, and so they want more. And then when they start eating things like proteins, shrimp, and these foods where these proteins can get into the blood, then if they're genetically susceptible, then they can get that severe allergic reaction.
So interesting. That's really new finding, because my daughter is actually anaphylactic to peanuts. So of course,
there you go.
and you know, she used to always love apple juice when she was little, right?
Yeah.
But then there's other factors there, like you said.
Oh, there are other
genetic component. And I know I read a statistic, 50% chance of your child having allergies if you have allergies, and I have allergies. So there you go. But that's interesting. Now, okay, so we talked about those sugars. What about other sugars? How does that come into play? Such as, you know, like eating a lot of white bread and white pasta and white rice, and because that turns into sugar, it turns into glucose, right?
Yeah. So starches, you know, what we see in bread and rice, potatoes, crackers, cereal, we love those things, right? I do love bread. You know, when I was a kid, I liked bread so much that fresh bread was often given to me instead of a cake, because there was something about fresh toasted bread that I loved.
Yeah.
So, you know, I just love that stuff. It turns out, unfortunately, this is sort of depressing, but those foods actually increase the risk for obesity too. And we did research on this, and The classic theory is that it breaks down to glucose. And then when you eat the food, the glucose levels go up in the blood. We call it high glycemic carbohydrates because these foods are rich in starch. So when they break down, they release a lot of glucose and it goes up in your blood. So like an hour after you eat, it's not uncommon for your blood glucose to be 130, 140, 150, and sometimes as high as 180 if you're eating a lot of carbs. And that stimulates this hormone insulin. And there's this theory, the carbohydrate insulin model, that says that when that happens and the glucose goes up, that insulin's released, moves the glucose into the cell where it gets turned into fat. And that's true. But our work found that there was a more powerful mechanism. It's still driven by the glucose rise. So when you eat these carbs, glucose goes up. But there's another thing that happens in the body. It isn't just the stimulation of insulin. There is an enzyme system. There's a mechanism where glucose gets converted to fructose. And that happens when you eat these kinds of carbs. And when the glucose level goes up, you're secreting insulin, but you're also converting glucose to fructose. And then the fructose, as I mentioned, tricks the body and shifts the energy from being turned into ATP, which is the active energy we use. Instead, it shifts that energy into fat, which is really a stored energy. So this is a very specific mechanism that fructose does. And when we gave glucose or carbs like rice, potatoes to animals, we could prove that they were making fructose. And when we blocked fructose metabolism by genetically knocking out that enzymes involved in fructose, so they could still metabolize the glucose, they could still secrete the insulin, but they couldn't break down the fructose. And when we did that, we could largely protect them from obesity. About half of the effects of glucose are through insulin, and the other half are through fructose. And like if you drink a soft drink that has high fructose corn syrup in it, it has both glucose and fructose. Well, the fructose is already half, so that's driving like half of it. But of the liquid glucose, half of that is being converted to fructose. And so about 3/4 of the effects of a soft drink are from fructose, and only 1/4 of it is from the glucose insulin pathway. So it turns out that like soft drinks, cakes, ice cream, all these things that make you fat, turns out to be mainly from stimulating fructose, and even though they contain glucose. And so this discovery that the body can make fructose turns out to be really important, because now what we're learning, Sandy, is that even other things like cancers, like heart attacks, that there can be local fructose production. Like if you have a heart attack, the heart will start making fructose.
Wow.
Yeah, in the heart. And the metabolism of fructose occurs in the heart. It's like a survival pathway. It's meant to help because it helps, put energy, store energy, and give you extra energy. And it tries to reduce how much oxygen you need and all these things. So it's supposed to be a good thing. But because of our diet and our genetics, humans are particularly sensitive to fructose. It ends up being a problem. And so there was a nice paper in Nature that shows that in a heart attack, that the fructose that's being produced in the heart actually plays a role in causing the heart disease. The thickening of the heart and all that is driven in part by this fructose. And cancers love fructose because fructose is quote a survival factor. So it helps the cancer live in a low oxygen environment, but it really is helping drive cancer growth. So breast cancer, colon cancer, liver cancer, pancreatic cancer, they've all been shown to be stimulated by fructose. And in fact, there have been a number of Nature papers suggesting that we should cut back on even dietary restriction of sugars can have benefits on cancer growth. So the rule out there should be, let's say you have, unfortunately, have breast cancer or you have liver cancer. Try not to eat a lot of sugar because it's actually the fuel that those cancers like. Now, if you're so sick and you're not eating any food at all, please eat anything you want. Don't think about whether or not you should eat sugar or not, because if you really can't eat, nutrition is so important as the first rule. So if you're not eating anything, eat whatever you can, and eat whatever you like. But if you are doing well and you are able to pick your foods and it doesn't have a big effect on you, try to reduce sugary foods and high glycemic carbs, because they get converted to fructose. So these are just wise moves, okay? And so
okay, well, where does alcohol fit into all of this? Because
yeah.
I know that alcohol is a big deal for a lot of people. They come home from work and they have, they with their spouse, they'll split a bottle of wine at dinner, and it's
Well, yeah. So I'll tell you my story about that. So when I was beginning my studies, this paper came out in the New England Journal, and what it said was that wine in low amounts could be healthy, and it was associated with less heart disease. And the data that they had in this New England Journal paper showed that if you drank one glass of wine a day, you actually did better than zero. If you drank 2 glasses of wine a day, it was about the same as drinking nothing. So that the benefit was gone, but at least it wasn't bad. And if you drank 3 glasses of wine a day, you were decidedly making things worse. Okay. So, and I knew from my work that, that hard liquor, besides its possibility that it could cause alcoholism, and alcohol can also cause liver disease, a lot of times hard liquor is mixed with sugar,
oh yes, yeah,
a lot of drinks, margaritas, pina coladas, which taste great,
sure,
but they have sugar in it. So I knew that the hard liquor I wanted to stay away from. Beer, believe it or not, raises uric acid very, very easily, and that's associated with obesity. And even non-alcoholic beer can raise uric acid and increase the risk for obesity. The beer gut's real, right? And the reason is because beer has brewer's yeast, which raises uric acid. Alcohol raises uric acid too, but beer is the worst one at doing that. So I was thinking, well, wine is the way to go. And so I would typically have a glass of wine at night, and sometimes 2. And I did this for years. And then about 5 years ago, maybe a little bit longer, we were studying fructose, and we discovered that, that the body can make fructose. And one of the things that we learned was that these high glycemic carbs could make fructose. And that they do that because they make glucose, and glucose can be converted to fructose. So when glucose goes up, you get more fructose. But there's also an enzyme that converts the glucose to fructose. And that enzyme gets activated by things that raise serum osmolarity, which means simply that, like salt raises the salt concentration in the blood, and salt can activate that enzyme. That's why salted French fries are so much worse than regular French fries, because the French fries contain the carbs that make fructose, but the salt stimulates the production of fructose.
Oh, wow.
You're right. So salt actually can drive obesity, but alcohol also raises the osmolarity. And so we realized that alcohol might actually stimulate fructose production. So we did these studies where we gave alcohol to animals, and we found, to our chagrin, that alcohol in itself raises the osmolarity and stimulates the enzyme that converts glucose to fructose. So alcohol doesn't make fructose in itself, but alcohol stimulates the conversion of glucose to fructose. So for example, pretzels are carbs, right?
Right.
They're like crackers. And when you eat a pretzel and it's salted, the salt helps convert that pretzel into fructose. But the alcohol will also stimulate that carb, the pretzel will be converted to fructose because the alcohol raises the osmolarity just like salt does. So when you eat carbs with alcohol, you really can make a lot of fructose. So it's sort of like a stimulus. So what we did is we gave alcohol to animals, and we could show that fructose production went way up, especially if you have them on a high carb diet. And then we had this really surprising finding. We found that when we gave alcohol, that the animals got fatty liver, and it's well known that alcohol can cause fatty liver.
Mm-hmm.
And over time, they can get liver failure from alcohol. So it's a major cause of death. We call it cirrhosis. And we found that the alcohol was causing the fatty liver, not from the alcohol, but from the fructose. And if we block the fructose, alcohol didn't cause liver disease. And about the same time we discovered this, another group also reported it. And now there's like 3 other groups that have reported it. So it turns out that alcohol makes fructose. It's been shown in humans, and it's actually the reason people get fatty liver and liver disease. It's from the alcohol. Now, here's another twist. This is like unbelievable. The craving of sugar is also driven by the fructose. So if we block fructose metabolism, animals, they still like sugar, but they don't crave it. They're not, the addiction component is really knocked out. And so when we blocked fructose metabolism in animals that were alcoholic, we could block alcoholism. And this led,
That's huge.
So I have a very large grant from the National Institute of Health to try to develop inhibitors of sugar to treat alcoholism. And I have drugs that I've made that I can block alcoholism in animals by simply blocking fructose metabolism. So it's my hope that one day we'll get something to be able to give it to people. But I'm still a ways away from that. But so there's a real link. And actually, it's been known for a long time that people who like alcohol tend to like sugar. In fact, there are papers on it. Like if you are from a family where there's alcoholism, usually those people in that family like sugar. And there's this really interesting finding as a physician. I've taken care of many, many people who get admitted with liver disease from alcohol. And so when they brought them to the hospital, all the alcohol is taken away from them. And they inevitably ask for soft drinks because they love sugar. And if they don't have alcohol, they'll start drinking it. And so I'll go into a room and a person who's got alcoholic liver disease will have these soft drinks on their table. And then I have to explain to them not to drink the soft drinks because the soft drinks also cause liver disease and they're being admitted for liver disease.
Right.
But it's because of this the craving carries over between the two. So alcohol and sugar are very, very linked. Rob Lustig, who's a great guy who writes about sugar and fructose, said that fructose is alcohol without the buzz. And he was talking about it because, fructose can cause liver disease, fructose can cause craving and addiction. Alcohol does too. But I don't think he knew at the time, but the two actually are really linked. They're really linked. And that's
okay.
Yeah.
Here's a question, because I've heard that alcohol is like the new smoking
Yeah.
or midlife. I actually read an article a while ago. Is it because of this whole connection that you're talking about with fructose? Because you were saying that sugar feeds on fructose.
Yes. Yes. So yes. So sugar craving is really linked with liking fructose. And here's a very interesting thing. If you take like an artificial sweetener, and you give it to an animal, they'll like it. And they'll get a little what we call dopamine release in their brain, which is kind of a hormone that creates a sensation of pleasure. Dopamine really gives you a pleasure response. And so if you eat sugar or an artificial sugar, you'll get this craving. And the animals like this sweetness and they get this dopamine response. But we've done this experiment. If you knock out taste, so you can make an animal that has no taste. And what's interesting, if they have no taste, they no longer like artificial sweeteners. The artificial sweetener does nothing, but they still love sugar. They still love sugar. Even though they can't taste it, they'll find if you like put two bottles and one has sugar water and one has regular water, and they can't taste the difference, but they can feel the difference. So when they drink the sugar water, they still get a dopamine response in their brain, even though they can't taste it. And when you knock out the metabolism of fructose, they don't care for sugar anymore. So
Wow.
they don't care for fructose anymore. They still like the glucose component a little bit, but doesn't really make them addicted. So they'll still, if it's like sugar that has both glucose and fructose, they'll still drink a little bit more glucose, sugar water than regular. But for example, if an animal, like if you give an animal sugar water, it will drink like 5 times the volume of water in sugar water. But if you knock out the fructose, they'll drink 1.5 times, 2 times. So they still like the sweetness of glucose, or the glucose, what it does to your body, but they don't care for fructose anymore.
No.
So fructose is the trump card.
Yeah, it sounds like it. So, and you did say something. I have to go back to this because you did say that you're giving the animals an enzyme to block the production of the fructose, right?
Right. Yeah.
So
like a drug.
what is this magic drug? Is this the one that you're working on for people?
Yeah. I'm trying to make a drug that will block fructose. And I'm not the only one. There's a lot of big pharma that are trying to develop drugs for this. And it has the potential of being, very beneficial for humankind. And so it's called a fructokinase inhibitor because the fructokinase is the enzyme that people are trying to inhibit. Mm. And when you block it, you can block like how sugar causes obesity, or like sugar causing diabetes, or sugar causing fatty liver, or sugar raising blood pressure. So it seems to have a lot of benefits.
Yes.
And, it could make a big difference. And if you spend your life doing research, trying to figure out what causes disease, you always would like to be involved in trying to find a cure for the disease. And the great thing about nutrition is we can have a major effect just by changing the kinds of foods we eat, reducing this and increasing that, drinking more water, eating less salt, eating less sugar, and we can have a great effect. But there are some people who, despite everything, they're hooked. They're hooked to their bread. They're hooked to the ice cream. They're hooked to their foods. And I want to help those people too. And so if we could find a way to help, make an impact, it isn't about money. It's about the ability to try to make a difference and to help people. I mean, I became a physician because I wanted to help people. And, so as a researcher, when you find something that looks important, you go, I'm going to try to figure out how to block that. And we knock out the enzyme. The classic thing is you use genetics, you make an animal that cannot metabolize fructose, and there are people that have that are knocked out. They don't have that gene and they're protected. No one's ever gotten obesity or type 2 diabetes with that mutation.
Right.
So they live normally. So that's why I'm trying to do it. But, I'm a little guy and it's, the likelihood of me succeeding is much less than, Eli Lilly or one of these big companies. And frankly, I just want to see it done. So I'm hoping that that we get drugs that can block this and that there's as effective as they look like they should be from studies in animals. And of course, there's always a little bit of a jump when you go from an animal to a human, but we are animals too in some respects. So there's a pretty good chance it will work.
Well, that would be fabulous because just like what you said, I know a lot of people who just can't really control that urge. And I do find that interesting that you're talking about the genetics, because I look at my mom, for example. She's that person that can somehow always have one cookie. And she's like, I don't need to have 5. But your father, he wants to have 5. You know what I'm saying? Like there's some people who just
have the willpower.
Yeah, or they just don't want it. Like
exactly.
They just don't want more. Like having that one is enough. So let's get into some of the science behind sugar or the correlation, because I know that you're doing some work on this between sugar and Alzheimer's.
Yes.
Yeah.
So let me tell you the story. So, the way that I get into, to move into fields like Alzheimer's and areas where I'm not a neurologist, right?
Yeah.
So the way I do it is I work with what I'm good at. So I'm studying my area of research. And if it looks like it's important in Alzheimer's or a disease that I'm not an expert on, what I do is I approach experts in that field. I tell them what I'm doing, and then usually I join forces with them to apply what I've learned in my field into their field. And so I'm not just doing studies in Alzheimer's without the assistance and work with neurologists.
Yeah.
So here's how the story happened. We were studying fructose. Originally, I was looking at fructose as a mechanism for driving blood pressure, because if you give fructose to an animal or a human, blood pressure goes up. And I was trying to link sugar with the development of hypertension. And in that process, we found that fructose was distinct from all nutrients in that it reduced the active energy in the cell and increased the stored energy. And this mechanism involved reducing ATP, which is the energy we use from moment to moment. And instead of making ATP, the fructose was preferentially making fat, which is stored energy. So the total energy is the same, energy balance is maintained, but it's making more stored energy than active energy. Okay, and the mechanism turned out to be to suppress the mitochondria, which are these little things in the cell that make ATP. So when it suppresses the ATP, the mitochondria, there's less ATP made, and then the energy goes to fat. It's really cool. All you have to do is suppress the mitochondria and you get this effect. And when we started studying this, we realized that it activated a series of things. It wasn't just stimulating fat, but when we activated this mechanism, animals started to get hungry. The low energy in their bodies made them hungry, the low ATP. They became thirsty and they started to forage for food. And they also became insulin resistant. And so this whole process, what we call metabolic syndrome, is kind of activated by fructose. And it's all related to dropping the ATP in the cell. And the way foraging is a real behavior. It involves searching for food. But you don't just say, I'm going to go search for food. What happens is you have to be hungry. You have to increase your ability to get around, so you're moving fast. You have to make quick decisions. You can't deliberate. You have to reduce self-control, because you don't want to, you're going to go into places that might be dangerous, and you don't want to say, hey, I'm not going to go there. That's too dangerous for me. So if you suppress self-control, you're more likely to be impulsive. You're more likely to go into the lion's den to steal the cookie, and so you get a little bit braver, a little bit. And then you also have to inhibit memory a little bit. You have to inhibit, especially recent memory. You don't want to remember that, how bad that lion looked when you go into the den. Right. So you have to suppress on it. So it turns out that foraging is a behavioral response. And when you eat fructose, you stimulate that. And the way fructose does this is it works on certain regions of the brain. So the cortex of the brain is really involved in self-control and reasoning. And so it will inhibit that. If I give fructose to a human, the blood flow to the brain goes down in those areas. And there's less glucose being metabolized in those areas. And in contrast, in certain regions of the brain, like the back of the brain, there's this thing called the occipital cortex that's really important for vision, and particularly picking out food. And that's called the visual cortex. And when you eat fructose, that's lights up. So if you see that piece of cake over in the corner, you not only do you see it, but you focus on it, and you know where the cake is. And that's part of the foraging response. You want to be able to see the food and have that desire and go for it and not have the self-control. And so there's an actual thing where when you eat fructose, certain regions of the brain are inhibited and other parts of the brain are stimulated. So there's been this big mystery about Alzheimer's. And the mystery about Alzheimer's is, it was first described in about 1900. And basically the brain shrinks down and you lose all these neurons, the cells that are really important in thinking and, everything we do. And so you develop dementia. And when they look in the brain, they see things called amyloid plaques, which are these accumulation of protein, of amyloid protein, and they get these tangles in the neurons that contain a protein called tau. And so everyone, when they first saw this, they said, this is a disease in which there's amyloid deposition. It's a problem with this amyloid. And so everybody started making drugs to try to block the amyloid. And there were 40 drugs that went to trial, and they all failed because it doesn't seem to be that this is the important thing to do. I mean, recently there was one drug that was approved that does reduce amyloid a little bit. So there is some benefit, but basically all these trials were negative. So I then said, okay, well, what if it's not amyloid, what's causing Alzheimer's? And so they said, well, maybe it's the changes are occurring before the amyloid actually forms. So they looked at Alzheimer's earlier in the course, before those amyloid fibrils are really and amyloid plaques are really depositing. And they found three things. They found that there was a little bit of inflammation in the brain, but they found that the mitochondria weren't making ATP. They were suppressed. And they also found insulin resistance in the brain. And yours truly, was looking at our work, and I go, well, geez, fructose is causing insulin resistance, and that's in the brain. Fructose suppresses ATP, that's in the brain. And fructose is causing inflammation, and that's the other factor in the brain associated with Alzheimer's. It was the same three things. And then, I started reviewing the literature, and if you give sugar to animals, they have trouble walking through a maze. They can't get through a maze very well. And there's direct relationships of sugar intake with shrinking brains and memory problems. I mean, the correlations have been there for a long time. And then if you give sugar to animals or high glycemic carbs or these foods that cause fructose production, you get that same thing. They get that mitochondrial problem. You get the insulin resistance in the brain. You get the inflammation. You have the trouble thinking. And over time, they even get the amyloid plaques. I mean, they even get the amyloid in the tau protein if you give sugar for months and months. So it seems like it's probably the player. And then when you look at the risk factors for Alzheimer's, you actually see that the risk factors include sugar intake, diabetes, obesity, and high glycemic carbs, salt, and alcohol, the three things that can make fructose. So it seemed like a perfect fit. And then when the people looked in the brains of patients with Alzheimer's, they found very high fructose levels, like 5-fold higher than normal. So I think the whole story's there. But the winning ticket, the one that's the most interesting, is that Alzheimer's affects certain regions of the brain and more than others. No one knew why. Why does it affect this area of the brain? It affects recent memory. It affects the cortex. And it turns out that it affects the areas where the fructose inhibits the activity. So when fructose inhibits glucose metabolism in the cortex, that's the area where the Alzheimer's develops in the recent memory. And so I realized that what happens is this: when you're eating fructose, you're stimulating foraging and you're inhibiting these areas. It's temporary initially, it just lasts for an hour when you eat sugar. But if you're eating sugar every day and you're inhibiting this thing again and again and again, over time, those little mitochondria start to fail. And when they fail, everything starts to go. And then you start losing the neurons and the ATP levels continue to drop. And you got Alzheimer's. So I think Alzheimer's is a disease of nutrition. And I do believe that this whole story is causing it. And what I'm telling you is, don't, go ahead and have a sugar, cake for at your birthday. I'm not telling you never to eat sugar again. I'm not telling you, just cut all these foods out. But what I'm telling you is that probably eating a lot of sugar, eating a lot of high glycemic carbs, drinking a lot of alcohol, all these things may actually increase your risk for Alzheimer's. And so what I would recommend, a healthy diet, a Mediterranean diet, or follow the diet in my book. I go into great detail about our work. So you might find some real pearls in that book about some tricks, like, for example, liquid sugar is much worse than solid sugar. Eating things slower will make a big difference. Drinking water can block a lot of these effects. There's a lot of benefit once you understand how it works. But anyway, so I'm hopeful that the nutritional thing will make a huge difference. But if not, getting a drug that can get into the brain and block this metabolism might also help. And so I'm hoping that it's my belief, Sandy, that all of these diseases, obesity, diabetes, hypertension, fatty liver, Alzheimer's, they're all part of one syndrome. And I don't think they're going to be around 40 years from now. I think that the science is coming out and we're going to find inhibitors, we're going to find better diets, and these are going to be diseases of the past. What do you think about that?
I hate to bash companies, but I don't think a lot of companies are on board, right? That's where the problem is it starts young. You're talking about, you kind of made me giggle a little bit because you're talking about that foraging and how, sugar puts you in that state where you're not necessarily thinking clearly either.
Right.
I'm like, this sounds like my teenagers with sugar. Honestly.
Oh yeah.
Like
it's addicting.
It sounds like my teen daughter. And then, I analyzed the Starbucks that she brought home, and
Absolutely.
oh,
Frappuccinos.
oh my God, one of these, and it was like, I said, this is bigger than your body. Like, why are you drinking a drink that's this big? Like, it was like bigger than a venti. And I think it had 55 grams of sugar.
Yeah, it's unbelievable. Oh my gosh.
So this is where the problem lies. It's almost like we want to do better, but this temptation is always there. And
Right.
I know, let's get into, because
Yeah, exactly.
let's get into what some of the little tips and tricks. And the reason this is very near and dear to my heart, the whole insulin resistance, because I was on the road even as a nutritionist. But I'm a 53-year-old nutritionist. I've got a few things going on, being in midlife, close to menopause or at menopause. And a lot of things are changing and shifting. And I see a lot of women having these issues where their midsection all of a sudden starts to grow, right? And then I'm like, oh, wait a second, my HbA1c is going up too. There's something going on here, right? And I had to make a concerted effort to change the way I ate. And I lost 4% total body fat. I became a certified metabolic balance coach. And I'll still I had my Lindt dark chocolate before I got on this call. So,
Good. Yeah, that's good.
you got to have a little bit of that little pleasure. I don't smoke. I drink very rarely. I eat whole real foods. So every once in a blue moon, having a little treat is good. So
That dark chocolate's good. There's no
except,
doubt.
but then they scare everybody with those claims about all of the heavy metals. Remember that came out in the news,
Yeah.
maybe a month ago. And so now it's like, okay, well, now I can't have too much. I have to be careful. But what can we do? What are some of the things we can do naturally to help inhibit this fructose, other than, don't drink tons of venti Starbucks, right?
Yeah. Yeah. So the first thing is the obvious, which not everyone can do, which is to reduce your sugar and reduce your high glycemic carbs and all those tricks. Okay. So but we can tell people, that, but it can be very hard to do. But there are some simple things that you can do that can really help. So the first thing is that, I think that if you can avoid drinking soft drinks or liquid sugar, you'll help yourself a lot. Fruit juice, cut that out. Eat a natural fruit if you really crave something sweet. That would be my first recommendation. Drink more water. We could actually, a lot of obesity is not just the sugar, but it's the salt. And it's this raising the osmolarity. And sugar actually raises osmolarity too. And we've been able to suppress the development of obesity in animals by increasing water intake. A very simple move. We found that people who are obese tend not to drink a lot of water. There's an association of not drinking much water and eating more salt. And too little water and too much salt do the same thing. Salt raises the osmolality. Not drinking enough water raises the osmolality. Raising the osmolality triggers the switch. Okay. So if you can drink more water now, there's been this quote myth. The New York Times called it a myth. Drinking 8 glasses of water a day is thought to make a lot of people skinny. And you probably have seen a lot of people running around with their water bottles, and many of them are very skinny. It really is true. But it's said, this is just a myth. The kidneys can do the work for you. They can hold on to the water for you. But actually our work shows that if you don't drink enough water, you have this increase in a hormone in your blood called vasopressin. And the vasopressin actually has a role in causing obesity. And you can measure it. It's called copeptin. It correlates with increased risk for obesity. It's a new marker for risk for obesity. And if you suppress it by drinking water, you can block a lot of weight gain. You can block insulin resistance. And so we should be drinking more water. Now, the question is how much? And you don't want to drink so much water that you can become intoxicated
Yes.
from water. So there are cases, there was some guy who drank gallons and gallons of water and then he seized and died. So you can drink too much water. But a good rule is to drink 8 glasses a day. And most people can drink 8 glasses of water a day without a problem, or maybe 6 12-ounce glasses, 8-ounce cups. That is healthy. And it's actually recommended by the Institute of Medicine to drink about 2 to 2.5 liters of water a day.
Yep.
That's healthy, okay? And what you want is that urine color. Urine color is a good marker of how much you're drinking. If it's dark yellow, it means you're not drinking enough.
Right.
If it's very light, it usually means it's good. If it's totally clear like water, yeah, drink your water.
I'm drinking my water.
Yeah,
I always
exactly.
have it with me.
Good,
Always.
good for you. So if you drink, if the urine is as clear as water, you're probably drinking too much. And, and if you have any questions, ask your physician. And there are 3, maybe 4 rules of, when you probably should be careful about drinking water. One is if you're running a marathon, when you run marathons, we tend to hold on to water more. So they recommend only drinking to thirst. If you just had surgery, you don't want to drink a lot of water in the post-op period because you can hold on to it very avidly. And if you have heart disease or liver failure or, real serious medical issues, you should talk to your doctor because some people will hold on. There's a medicine called hydrochlorothiazide, which is a medicine used to treat blood pressure. And especially if you're older and you're on that medicine, it can make you hold on to water too. So if you have any questions, ask your doc. But generally speaking, just drinking water can make a big difference. And if you drink before the meal, get a glass of water. When you go sit to have lunch, drink the water first and then eat. Drink the water before dinner and then eat, because it will force you to drink it. Because if you just have the glass there, you may just be focused on the food because that's really what's attracting you. And then, you forget to drink the water. So if it's like a requirement, it's like that vitamin you have to take or whatever, your medicine you have to take, make it be your medicine. You drink a glass of water before each meal. Before a snack, if you're going to eat a snack, you get a glass of water, drink it first, then eat the snack. And it actually helps. Like if you eat some salted nuts or something, the salt will activate the switch. As soon as you get thirsty, you've activated the switch. But if you drink water first, then you can eat some nuts and you probably won't get thirsty because you've dropped your serum osmolality and then you correct it back to normal rather than make it go up and then try to bring it back to normal.
Right.
So it turns out that how you do it makes a difference. And so these are like wise things. There are other tricks, you can get a continuous glucose monitor. They call it a CGM. And you put it on your arm and you can have it hooked to your cell phone and it will tell you what your blood glucose is during the day. And then you can figure out which foods you eat raise your glucose. And if you know that if your glucose goes up to like 150, you're making fructose, not just in your body, but in your brain. You can be making it in your brain. You don't want that. So you can figure out which foods you can eat, which ones you can't. And there are tricks like you can eat bread and your glucose may go up. But if you put like avocado on the bread, the avocado will block the rapid absorption of the bread. And so you end up not raising your glucose. So there are tricks where you can eat that bread that you want. Totally. And like if you eat a cake by itself an hour and a half after dinner, so if you delay on the dessert, the cake is going to cause activation of the switch much quicker than if you have the cake at the very end of the meal, because you're going to have all these other foods in your stomach that are going to slow the absorption of the sugar. And it's as I mentioned, it's the concentration of fructose that hits the liver and the brain that counts, right? It's the concentration. So if you make it the absorption slow and it trickles in the fructose, it's not going to activate the switch as opposed to like a big wave, you know? So there are all these tricks. I encourage you to read my book. I've got lots of these little tricks. And some of them are science based on actual studies. Like we did a study with apple juice, and we found that if we gave it to humans, this was a human study, you give them a big, like a liter of apple juice and have them drink it in 5 minutes versus an hour and a half. There's a huge difference. If you drink it in 5 minutes, you're activating the switch. You're going to get that vasopressin. You're going to get all that stuff happening. But if you drink it slowly, it becomes like a calorie, you know. It's still a calorie, but it's not, shunting the energy to fat.
Okay, let me ask you this question because I love it. That actually eating the dessert at the end of the meal, that is one of my most favorite tricks. So instead of waiting 2 hours later and then having dessert and then raising that glucose again, you've got that buffer in your stomach already. It's a nice little buffer. That's one of my favorites. But I have to ask you this. I'm sitting down, I'm having my meal. I have heard 2 different ways. Do you go with the veggies first or do you go with the protein first? Let's say you have a protein, you have your veg, and then you have a little bit of starch. Which would you pick first?
Okay, it's a great question. I have not studied this, but I can tell you what some of the science says.
Yeah, tell me the science.
So there is a very common, it's sort of a new hypothesis, but it's a pretty cool one, called the protein leverage hypothesis. And this hypothesis says that that if the food is disproportionately low in protein, that you're basically, the cells feel like they're nutritionally deprived, and they want more food. So like if you're eating a diet that's high in carbohydrate and fat and low in protein, you end up eating more than you would normally eat because you're trying to get that protein. And that protein really carries with it satiety, meaning that if you eat protein, it can help quell the appetite so that you don't eat as much. So based upon the protein leverage hypothesis, you would want to eat the protein first. And so that makes sense. Now, challenging the protein leverage hypothesis is the fact that, we know that high carb and high fat drives obesity. So, it may not be the fact that it's low in protein. It may really be the fact that the diet is high in carbs and fat. And there was one study where they gave people different levels of protein and they didn't see that satiety effect. But having said that, we know that protein is very, very important in diet, that people often aren't eating enough. And I think eating the protein first makes sense. And if there isn't some satiety from it, like some of these scientists feel, it certainly would favor eating, the protein first. Now, the other side of it, though, is like things like certain vegetables like lettuce and broccoli and so forth. They have a lot of fiber, so they're going to help slow the sugar and things like that. So, so it's a hard call. I don't absolutely know which would be best, but the protein leverage hypothesis would say protein first and vegetables after. And I personally think that, after this interview, I'm going to go have a Caesar salad with chicken.
Yeah.
So I'm going to eat both. I'm going to eat them both at the same time. And I'm not going to worry about, but I'm going to try to get my protein and my veggies.
Yeah. I mean, I listen, I feel like like you said, there's benefits to eating the salad first, because then you've also got, if you've got a salad that has all the bitters, it's like digestive enzymes going to work, right? So but I always go with protein first. That's just what I've been taught ever since I've lost that 4% body fat, and it works for me. Now, okay, let's try and summarize this up. Is there anything that you want to add about sugar that we didn't talk about before we close off?
Well, there's a lot more, especially for, in terms of women, there's effects of fructose on pregnancy that we haven't talked about. We recently linked it with preeclampsia, for example, this terrible complication. This pathway, the uric acid, is also very important in menopausal, postmenopausal women, because uric acid goes up, and we think that that's one of the reasons why following menopause women tend to gain weight and develop some of the same complications as males. And so there's a lot more to the story, but I think if people are interested, I would recommend getting my book. It's 300 pages, and too much stuff for me to talk about in this 1 hour. But yeah, there's definitely more there. There's a whole story about how this pathway can cause heart disease. And there's now data suggesting that uric acid crystals, for example, can be found in the plaque of the coronary arteries. And so particularly people who start getting gout from eating a lot of sugar, there's this risk. So there's a lot of stuff coming out. It's a big field. There's a lot of diseases. And so there's still a lot more to learn. So.
Okay, so let's end with this. How many grams of sugar per day should an average size woman and then an average size man have? I don't know.
Oh, yeah.
What should we shoot for max?
So there's a lot of small amounts of sugar in vegetables and stuff.
Right.
And I don't count that because when the sugar content's very low, you can become a counter, and yet we know that the first few grams are inactivated in the gut. And so, what my recommendation is, really, people are eating, maybe 75 grams of sugar a day currently. And I think that we're easily eating twice what we should be eating. And, probably it's closer to like 30 or 40 grams of sugar would be sort of the max. And, obviously, adding pure sugar to drinks and stuff, or like to coffee, I don't recommend that. So my approach has been more to try to reduce very significantly, sugary foods, and to try to move more towards more like a Mediterranean diet. Probably it would be a good way, or like a low carb diet would be a wonderful diet. And so I think those are really healthy diets. I have my own diet that's based upon my studies, but I think that these are good diets. The Mediterranean is a good diet. The low carb diet is a good diet.
Yeah, I concur. I personally feel like when I eat that way, I also feel my best.
Good.
So, yeah. So thank you. What's your website, Dr. Johnson?
It's drrichardjohnson.com. And so just drrichardjohnson.com. That's easy. I have an Instagram, Dr. Richard J. Johnson. And I have a Twitter account, rjohns11 @ I guess. And so, but a good place is my website,